Okay guys, so let us talk about undervolting through curve optimizer on AMD processors. So this uh, PBO2 feature is only available for the Ryzen processors from Ryzen 5000 series. So Ryzen 5000 and Ryzen 7000 both will support PBO2, and Ryzen 3000, 2000 and 1000 unfortunately does not support this PBO2. So if you want to do this curve optimizing method, you will need an Ryzen 5000 series processor. And also previously there was only compatibility with B series B550 and 500 series boards, but now they have also brought compatibility to B450 boards. Me personally, I'm using an B450 board from MSI, so we were able to see the curve optimizer settings on the BIOS. So they have pushed an microcode update which will enable this for also B450 boards. So let me explain what this curve alteration is all about. So through PBO, if you enable it normally means what happens is the algorithm will take control. I think the algorithm from the motherboard will take control and it will push the processor as far as the motherboard can provide power. So in my case, my motherboard was able to provide until 110 watts to the CPU. So it used to push so far that the CPU used to consume 110 watts and it used to heat up a lot, and due to that heat also it's not safe for the chip, and due to the higher power consumption also my electricity bill increases. So what I did was I used the feature PBO2, and I disable the smart control, and what that does is that it will remove the control from motherboard and push it to the processor. So then the boosting algorithm will be based on what AMD has configured in the processor but not on the motherboard. So now what will happen is your power consumption will reduce significantly with a little bit of performance loss. That is like a negligible quantity. So I will show you on the future slides how we will be able to see the difference there. So what I did was I enabled PBO2 and enabled curve optimizer. Through curve optimizer, I was able to like decrease the voltage of an CPU at a particular frequency. So what happens is the power is voltage into current. So when you decrease the voltage, naturally your power consumption reduces. So that's what this graph shows. So the first line is the default PBO and second line is the PBO curve optimized. So here you can see the CPU needs in the first line, the CPU needs a higher voltage to achieve the same frequency. But on the second line, you're able to see it able to reach that same frequency at a lower voltage. But this tuning has to be done in increments of values so that you can identify instabilities when it occurs and you can roll back the changes. You can't hit it with an solid higher value. So what you need to do is you need to like increase the offset by 5. So the offset goes from 0 to 30, and between these two values, like the voltage will differ from 0 to 150 millivolts. So it will be controlled like that. So on the next screen, you can see what is the actual behavior is like. There are two CPUs, that is the curve optimized PBO1 and the stock PBO1. Stock PBO1, what happens is the motherboard limit is so high that it pushes a lot more voltage into the CPU to achieve that little bit of more performance, and due to that the power proportionately increases at an exponential level. So when you reduce the voltage in this equation as I have shown here, you will be able to see like as we have reduced the voltage, naturally the power reduces. So that's what happens here. Also maybe the clock, clock speed might drop on some cases when you don't have a very good quality chip. So we can also alter it by we can also enhance it by altering the FCLK chipset frequency, or you can slightly overclock your chip based on that. Or an base clock overclock will also be good. So that we can do. But basically, what happens is an Ryzen CPU can work and can play games even at 1.75 gigahertz. I have seen that behavior. So what happens is you can also test it out. So you can enable power saver mode on Windows, and when you open any game, it will only push the clocks higher when there is absolutely no way to run the application on the lower clock. I have played Cyberpunk, and Only on intensive areas I was able to see the clock reaching 2.5 gigahertz only, and most of the time it was in 1.75 gigahertz, and the frame rate was also at 60, and I was able to see a lot of stutter at that frequency, but it was able to achieve that. So basically, how the Ryzen CPUs are configured out of the factory is for utmost performance with utmost stability. So that's why, like for safer side, they configure it with very high power consumption and other things like that. So what we can do is we are tuning that value. So AMD has configured it to be as safe as it can be, but we are tuning it to match the power consumption with our safety. So that tuning depends upon chip to chip. So some person might get a higher clock at a specific voltage, and some person might get a little bit lower clock at the same voltage. So that is depending on the sample which you get. You might get a golden sample or you might not. So that depends entirely on that thing. So that's what I'm doing here as a part of curve optimization. So on the next slides, we will see like what changes I have seen as a part of this curve optimizer. So as you can see here, I have ran benchmarks on different settings, and I was able to like calculate what was the performance I was getting out of my CPU. So as you can see here, I have ran benchmark on four settings. So one is the 5600X in stock configuration, next one is at default PBO, and next one is with game mode turned on MSI boards. So in other brands, I'm not sure what this might be called, and the next one is the curve optimized one. So here you can see the scores, and this stock one has only 10,631, and the normal PBO one has 11,519. The game mode one has 10,980, a little bit more than stock, but I think in MSI boards this is a feature which like overrides PBO, so I'm not sure. It was enabled, both were enabled when I created this setting, but I think this game mode overrides PBO and it's somewhere between stock and PBO. And at last, the curve optimized one where I have applied minus 30 as the offset. So here you can see from stock to PBO there is a drastic increase of around 1000 points. But from normal PBO to curve optimized PBO there is a little bit decrease of around 100 points, but it is almost equal. And this difference was with half the power consumption as much. So this ran at almost uh, 115 to 110 watts, and this one I was able to see around 70 watts. So not half, but around 40% lesser wattage. So that's really good for power consumption and the longevity of the CPU. So here also you can see the single core scores, and this game mode is something messed in MSI boards. It's so low. And also here you can see the score, single core score, that is 1512, is greater than 1507 of the normal PBO. So I will explain you why this is. So this is because AMD CPUs are created in a way where it will check for the headroom. So previously higher voltage was applied, hence higher power was consumed, so higher temperature was there. So the headroom was almost reached previously. So now when I created curve optimization, what happened was the headroom came, or to say the consumption was not as close to the headroom as it was in normal PBO. What happened was as the voltage decreased, the heat decreased and the power decreased. So the processor saw a little bit more headroom and it boosted a little bit more. So that's why you are able to see this difference in scores between single core scores between the normal PBO and the curve optimized one. So the temperatures, I will show the power graphs next, but we will go through the temperatures first. So the temperatures over here you can see at stock it was both was locked at 61 degrees Celsius, both single and multi-core. But in normal PBO, the temperatures were so high for multi-core that I was able to see around 74 degrees Celsius. This is within 240 Arctic liquid freezer 2 like radiator. AO cooler. So that is an extra thick radiator with a very efficient pump. So this is one of the best coolers in the world right now, but even that will let this processor heat up to 74 degrees Celsius. And the game mode, actually the game mode, it is a little bit less powerful than even the stock. You are able to see it from our benchmark scores. So due to that, I think the game mode is a little bit cooler than the stock configuration, but this results in a much lesser score. That is not good. So let's go to the curve optimized one. So you are able to see almost the single core scores are almost equal. So that doesn't matter. But the multi-core, I am able to see an 13-degree drop here. So this is massive, 13-degree drop. So this will help with the longevity and also the power consumption. When an electrical device heats up, it will need more current to do the same work which it was doing previously to when it was heating up. So the resistance increases with heat, so more power will be pushed, and resultingly the efficiency will be lower. So now the processor is running much more efficiently than before. So the power consumption over here, as I was telling. So at stock, I was able to see 77 watts limit both for single and multi-core. The single core scores wattage limit is for a single core wattage. I'm not taking the average wattage of the CPU, but the single core wattage. And when I turned on PBO, during single core, it was surprisingly consuming less wattage than stock. I think it's related to the algorithm, but the multi-core was crazy. It was around 110.5 watts. It's too high for a processor, uh, especially in Ryzen 5000, Ryzen 5 series processor. So 110 watts is okay for an 5700 or an 5800, but it's not at all okay for an 5600X. So next above you can see the curve optimized one. It is the single core is running almost 8 watts lower, and the multi-core is almost like 40 watts. So that is a significant drop from here. So that was really surprising to me. Also, this drop is with an very minuscule performance loss. I would not say it as a performance loss, it's almost equal. So as you can see here in multi-core scores, uh, yeah, so in multi-core scores, as you can see, it was around 118 points. So that is the 118 out of 11,000 is an minuscule part. It's around maybe 1% or 2%. So that doesn't matter at all. So I'm able to get the 99% of the score with around 60% of the power. So that is a really awesome increment of an efficiency for that CPU. So that is really good. And next, the VRM temperatures of my motherboard. So at stock, it was at 49 degree Celsius locked because it was not boosting that aggressively. And in PBO normal config, I was able to see for multi-core 53 degree Celsius was the max. And similarly, on curve optimize, I was able to see it as 50. So that is a really good transition VRM temperatures. VRM temperatures doesn't differ as much as CPU temperatures or anything like that, because VRM is not actively cooled, and it will always reach a steady state of around 45 to 48 degrees Celsius. So this is a 2-degree delta over the normal temperature which I see during idle or mild load, and this is around 5. So that is really good. And V-core temperatures, actually, the core voltages, as you can see, single core max core voltage, you can see the orange line over here, and the curve optimized one uses lesser voltage. So that's what I was telling. When we reduce the voltage to a CPU due to the power calculation formula, what happens is when you reduce a voltage to a CPU, the associated power also reduces. So that is why we are also seeing a lower temperature and higher efficiency for a CPU. So the CPU clocks. So when I completed this alteration, I was able to see the CPU on all conditions, it was hitting at least 4.65. The rated boost for this CPU is 4.7, but I was only able to see around 4.65. Maybe my motherboard might be a slight limitation, as it is an working class pro motherboard, but not a gaming board or an well featured motherboard. So here you are able to see the frequency is almost same, but without me altering anything, I was able to see an uh, 20 megahertz increase with the curve optimized one. So that is also a good one. So here you are able to see the CPU has seen a headroom to boost a little bit further more. So with this configuration, now I'm confident that I can also boost my CPU to 5 gigahertz But I'm not sure if Ryzen 5000 is efficient enough to go to 5 gigahertz. But the newer Ryzen 7000 CPUs, they have an working frequency of 5.5. So yeah, so the main objective of this curve optimization is to reduce the power consumption and to increase the efficiency, resulting in lower temperatures. So that is the real good thing about this curve optimization algorithm. And the average core clocks, which I was able to see during Cinebench for an CPU is what I have mentioned here. So you're able to see in the curve optimized one, it was running a little bit lower frequency because the algorithm to boost frequency is not as aggressive as it was in normal PBO mode. So actually this doesn't matter. This depends on the workload and the situation. If some background tasks are running means it will boost up. So this will change based on your circumstances. And I am showing you the Cyberpunk 2077 CPU temperature. So when I played it with stock PBO, I was able to see at a higher temperature like 63.5 and an average temperature of 56.3. And after curve optimization, I was able to see a 9-degree drop. And averages has also dropped similarly to the max. And this is a really good result. Almost 65 to and 55 degrees Celsius temperature is around like 10-degree drop, and this is really good. And also the power consumption was very low. I will show it on the future slides. And here Spider-Man, actually it is a little bit of an CPU intensive game also, I would say that. And you are able to see my CPU is reaching around 65.5 degrees Celsius, and on average it was around 60. But after I optimized it, I was able to see 54 and 48, which is around 10 to 11 degrees cooler. And this also resulted in a lower power usage, which is also and greater efficiency of a CPU. Also, this alteration did not provide any instabilities or anything like that. So once you create your curve optimization, run a stress test, and you need to check if your system is stable enough to run this. Next is Dying Light 2. So Dying Light 2 is generally not much of an CPU intensive game. So I have designed the test suite like one CPU intensive, one medium, and one not much CPU intensive. So Spider-Man is a bit CPU intensive, Cyberpunk is medium, and Dying Light is not CPU intensive. So even in a title where it's not intensive enough, you are able to see difference in temperature. So anyways, the intensity might be less, but even here we are able to see that due to lower voltages, we are able to see lower temperatures. So the CPU power, which I mentioned over here. So here you can see the curve optimized one is having a little bit higher power consumption on the max power because this occurs when there is a spike in CPU usage. So texture decompression or any background processing might happen. During that time, there was a spike. So due to that, I'm able to see 61 watts over here, but actually the 68-watt measurement, this was without the spike. That is a small incompetence from me designing this part. But actually in Ryzen 5600 with stock PBO, I was able to see as high as 80 watts actually in Cyberpunk. It used to run at 80 watts during a texture decompilation or anything like that. So it was a massive difference from stock PBO to and curve optimized one. And similarly, you can see in averages, you can see that difference. So it's around like 17 watts. So that is a very substantial number. And for Spider-Man, similarly, you can see here, it used to run at 82 watts and 75 watts average, but now it's running at 57 watts average. So that is a 19 to 20 watts drop. So that is substantial and substantially very high percentage of the CPU wattage which was dropped. So that's really good. And similarly, the max was also 65 watts only for the even with spikes also. So previously it was 82. So that was in greater wattage consumption. For Dying Light, for an title which is not CPU intensive, also you're able to see 5 watts drop in the max, and in average also you're able to see a 5 watts drop. So how much ever intense the game might be or the application might be, there will always be a wattage drop which will increase your efficiency with lower power consumption and very low temperatures. So that's good. and the voltages which I saw while I was gaming. So for Cyberpunk, when it was at stock, I was able to see 1.34 volts, but after curve optimizing, I was able to see 1.18 only. So that is a very good drop. Similarly, for other games, for Spider-Man and Dying Light, also you were able to see like a significant drop. And if you want to pause the screen and see the chart which I have prepared to compare all the values which I received, you can pause it here and look into it. So that's why I have provided this. Thank you for watching this video, and please do subscribe to my channel. I have been posting some videos recently, and I will be posting a lot more technology videos and tech review videos in my channel. So if you are interested in watching those kinds of videos and in-depth technical videos and circuit analysis videos, I will be posting those in future. So please do subscribe to my channel. Thank you for watching.